We're going to be talking about points, lines, and planes today. And so when we have, here we got a building and we got some points. See, I'm going to point to the points. We've got lines. Sometimes there's lines connecting 2 points. Sometimes there's lines that aren't connecting 2 points, like this line that's missing right here, it looks like there. So we've got points, lines, and planes. We've got these flat surfaces like the ground here, and we've got planes that we can't see right now. If we were to connect the top of these, we have planes. So points at the end of the 2x4s, lines going across the beams, and planes, that flat imaginary surface on top and the flat surface we can see on the bottom. Points, lines, and planes. And these are the basic structures that we will use to set up our understanding of geometry. Everything can be defined or boils down to these basic three things: points, lines, and planes. The formal study of geometry goes all the way back to about 500 BC when this guy named Euclid wrote a book called The Elements. And in this book, he started to formalize the study of geometry. When the Greeks thought about mathematics, they thought of it in terms of geometry. And so to start off, before he could describe all these different geometric structures, he had to have some basic things that can't really be defined. And the first one is a point. So a point is something that has 0 dimensions. It has no length, no width, and no height. It is just a location or a point. We draw a dot, and we name points with capital letters, always capital letters. Okay? Now, if we have a couple points and we connect all the points in between them and extend this forever, we get what's called a line. And if you try to define a line, it's kind of tricky. It's kind of imaginary. It has one dimension. All right, it's kind of like if you are stuck on this line right here and you wanted to move. Well, you can move you're stuck here. You can go forwards and backwards. You can't go up, down. You can't go left and right. That's your one dimension. It's just gonna forwards or backwards. All right, and so we represent that by a line that goes through all these points. It extends in both directions here, and it never ends. All right? So it never ends, and that's important. The way that we name a line is we name it with 2 points, because through any 2 points, we have exactly one line. You pick 2 points, a point here, that's an ugly point. There's a point there. And assuming that those are really small points and not as fat and ugly as I drew them there, then there is only one line that goes through those. All right? And we give that line a name, and the name comes from those 2 points. So, all right? So we name this line that we have drawn over here, we name it line AB. And so we're going to write that like this, AB, and we're going to put a bar with arrows over it. Real important that when you name these lines, you put a bar and arrow. Now we got this other structure. It's called a plane. Some things they kind of, you can go up and down, left and right, okay, or forwards and backs, left and right, okay. A plane has 2 dimensions. This is a flat surface like that floor of that building we just saw. And so it's represented by a shape that looks like a floor or a wall, okay? We draw a parallelogram. So when you want to draw a line, we kind of make it look like a flat piece of paper that's kind of laying down, all right? And through any 3 points, we have a plane, as long as those 3 points aren't on a line. Okay. Now it is important too to kind of keep in mind this plane goes on forever. You got to imagine this flat surface going on in all different directions. Okay. So if we have 3 points, there's exactly one plane. All right. Kind of like the chairs of a the feet of a tripod. Okay. If you have a tripod kind of stool or something like that, okay, there's my stool. If it's got 3 feet on it, those 3 feet will land on a plane. All right? So you can use 3 points that are not on a line to name the plane, or we can use one letter. So like this plane right here, Notice these are points, point A, point B, point C. So one way to name this plane is to name it plane ABC. That's because it goes through these 3 points. Another way to name it, because this M right there is written, notice there's no dot next to the M, we're going to call that plane M. So sometimes we like to name a plane with a single letter without a dot, and sometimes we use points on them to name them, all right? Now let's see how this works in practice a little bit. So we'll go kind of quickly through this and practice more in class, but if we have the question says, give 2 other names for PQ and plane R. So this is kind of 2 questions in one. Well, first thing we have here is we have this line, PQ. And so that's this line that's kind of poking through that. Well, that line goes through P and Q, so we can also take that name and we can flip those around. It doesn't matter, all right? So we can flip those names around. If we wanted to name plane R, well, plane R is this thing down here. So that thing there is plane R, and plane R can be named by 3 letters also. Now, by the way, there is no special symbol for plane. We just have to write the word plane out. So we need to pick 3 points like V, S, and T. Okay, how about that? V, S, and T. It doesn't matter what order they go in, but we can't pick S, P, and T. That would be no good because they're on the line. We could pick V, P, T, but they got to be 3 points that are not on the line. Now we have this thing called collinear. Collinear means on the same line. Okay, so the question is, can you find 3 points that are on the same line? Well, it looks like S, P, and T are on the same line. Well, what if we look for 3 points that are not collinear? They're not on the same line. Well, how about, let's see, P and T, those are on the same line, but if we pick V, P, T, and V, that would work. There's more combinations, but P, T, and V, they're not on the same line, so that would be a good answer. How about 4 points that are coplanar? Oh, what does coplanar mean? Well, if collinear means on the same line, coplanar means on the same plane. So they all live on that flat surface. So can you find 4 points on that flat surface, that shaded tan surface there? Well, looks like S, P, and T are all on that. Is R on that? Well, wait a minute. R is not a point. Don't use R for a point. There's no dot next to it. But we can use V. So how about S, P, T, and V? Those are all on the same plane. So one more question. That's kind of 2 for 1 here. Give 2 other names for ST. So ST, we'll highlight that in red here. It goes on forever. How do we name that? Well, to name that, we need 2 points. Just 2 points on the line. How about P and S? That would work, right? PS. Got to put that symbol over the top. How about PT? Those are 2 points that are on that line. Put the right symbol over it. Okay? So that's that question there. Now name a point that is not coplanar with Q, S, and T. So kind of a different question here. So Q, S, and T are here. Well, wait a minute. They don't even look like they're on the same plane. But they actually are. Okay, there's a plane that kind of goes through here. Okay, imagine this piece of paper that kind of chops vertically through this flat plane. And notice that P, S, T, and Q are all on that. All right, there's P, S, T, and Q. But this guy hiding back here that I've kind of covered up a little bit is V. And so V, I'm keep erasing it. V is our answer there. So V is not coplanar. Okay. A last few undefined terms here, all right? So we're going to think about this line AB, 2 points, A and B, and a line that goes through those and goes on forever, all right? That's a line. That's AB with a bar and arrows, all right? So we have something called a line segment, which is this part right in between 2 points. So the line segment, we're going to call this AB with the bar over it, or we'll call it segment AB, is just this piece that goes between A and B. And we have a special name for these. They're called the end points. All right, the end points are at the end. That makes sense. So A and B are called the end points, and all the points in between them on the line segment are part of the line segment. All the points in between them on the line. So note that this line segment AB can also be called BA. Doesn't matter the order. Order doesn't mean anything here because we can start at A and end at B or vice versa. Now, we can also talk about a ray. A ray here, going back up to our original one, is when we take the part of the line that starts at A and goes on forever to one direction. Or we could start it at B and go the other direction. But this is called ray AB. So we write it as AB with an arrow over it. And it consists of the point A. It's called the endpoint. Has one endpoint now, not two. And all the points that are on line AB, I'm going to put the line over that. That lie on the same side of A or as B. So in other words, okay, that's a lot of words there. So all the points that are on the same side of A as B is, okay? It's going from A through B, okay? So it's very important to notice that AB, ray AB, and ray BA are different. These are different rays. And if we look at our drawing, ray AB is what we have shaded here. It starts at A and goes through B. Ray BA starts at B and goes through A. And that's a very different part of the line, okay? Now, we're also going to talk about these things called opposite rays. And opposite rays, to finish this off here, are rays that go in the opposite direction, but they share an endpoint. So, if we have C in between A and B, so that point C is on the line AB, and it's between A and B, then we have two opposite rays. We've got this ray that's going this way, starts at C, and goes to the right. You know what we call that? We call that CB, arrow going from C to B. Then we have this other ray that starts at C and goes through A. We call that ray CA because it starts at C and goes through A. So those are opposite rays, all right? And that'll show up at different times. Missed a drawing here, so before we go too far, let's draw ray AB. So ray AB starts at A and goes through B. That is ray AB. So this is the picture of it, and this is how we draw it, or this is how we name it. All right, so a couple quick thoughts here. Here we got a little drawing. We got GH. Look at the bar. That's a line segment. That means we just want it to end at G and H. Is there another way we can name that? Sure. We can call that HG with a bar over it. So that's a line segment. Okay, now we got a whole bunch of rays that have an endpoint at J there. So if we want to name them all like this question asks us here, we've got one that goes from J to G. That's this guy. We've got one that goes from J to H. By the way, those are opposite rays. We've got one that goes from J to F. And we got one that goes from J to E. All right. So that's how we work with those. And we'll use that in class to talk about points, lines, planes, line segments, rays, and opposite rays.